like this. Okay, I think everyone can see you now.
Okay,
So please go ahead, Harnoor.
sure. Hello, everyone. Good afternoon. So, the topic of my talk today is We Are People Are People First, Deconstructing Sexual Identity Stereotypes in Large Language Models. This work was jointly done by my peers at CMU, Preetihan Saili, and Professor Emma Strubel. Let me start my talk by explaining what bias and context association mean in context to large language models. As you can see, in both the cases, the output of the large language model has some terms that relate to like the field of medicine. That is because of the word surgery in the input prompt. That is where we get the contextual information from. However, in the first sentence, the output is precisely leading the operation, and in the second sentence, it is carefully assisting the doctor. The large language model is basically shows bias association with the trigger words man and woman in this case. Previously, people have worked on template-based prompting methods for next word prediction and for text-to-text generation. In both cases, they have mainly focused on bias association, and there has been very minimal attention given to the context association. This leads us to our first problem statement, in which we hypothesized that large language models perpetuate measurable and quantifiable bias against queer people. As I previously explained, that the output of large language models is influenced by bias and context association. We introduce bias association from sexual identity trigger words and introduce the context association from a bunch of biographies, which I'll be explaining later on in the talk. So our work focuses on the prompts that contain different contextual information, which is in contrast to the things that people have done previously. Now, let us talk about what type of bias are we looking at. Yeah, so large language models often depict queer individuals as struggling, and they perpetuate harmful stereotypes that create an unfavorable representation of them compared to their straight counterparts. This is an example of representational bias, or you can say that there is a representational harm against queer individuals. Qualitatively, what we observe is that the output of large language models for queer individuals include the words that show their struggle with their sexual identity. It is important to acknowledge queer struggle. However, it is equally important to look at other facets of their personality. On the quantitative front, what matters is not just the content of the output of a large language model, it is the words that are used to describe an individual. And our mother, Taylor Swift, has said something in this context, and I would like to click on the piano and let it magically do its work.
There seems to be specific words used for women and specific words used for men who do the same exact thing.
Oh yeah,
You know,
yes,
like,
absolutely. What are some of these words?
Okay, so all right. So a man does something strategic. Woman does the same thing, calculated
Or manipulative.
Yeah. Manipulative.
Yep. Yeah.
A man stands up for himself. A woman throws a tantrum.
Right.
Right.
Okay.
I mean, you can go on.
Yeah. So the methodology that we used was that we took Wikibio dataset, which has a bunch of biographies of famous people. We gender neutralized those biographies and append those with marked sexual identity words, pass it through a large language model, and do some computational fairness analysis on the outputs. The models that we used were these, and I guess maybe I'll just show you the example for a walkthrough of this methodology. The first sentence is basically a snippet from our Wikibio dataset. It's a biography of a person called Hussein Dawood, who is a Pakistani industrialist, educationist, and a philanthropist. We gender neutralize this biography using they, them, theirs algorithm. We replace the name so that the large language model is not like unintentional. It does not basically like get biased because of a like famous person's name. And then we have like 5 prompts from this gender neutral biography. One is without appending anything. The next 4 are basically we append the sentence. Imagine that the person being talked about is like a straight man, straight woman, gay man, or lesbian woman. Okay, so the results that we see of a large language model's text completion task is that in control, straight men and straight women's outputs, the large language model focuses on the business acumen of the person, that how they actively contributed to entrepreneurship and innovation in the country, how they were a successful businessman, and they were a prominent figure in this community. However, in the output of gay man, we see that it starts with the phrase, despite facing discrimination and prejudice, which is fine because it's acknowledging the queer struggle. However, if we look at the output of lesbian women, it just talks about their philanthropic work and how they created more inclusive workspaces and communities. It does not talk about how their aptitude and like their business mindset, which is kind of sus. So on the computational fairness analysis front, we plotted like TS-new visualizations of TF-IDF embeddings of the outputs of LLM. What we observe is, as you can see, that the red and the blue dots, which are the control and straight men, they're pretty close to each other, which means that the straight men's outputs are pretty similar to the controls outputs. And secondly, what we observe is that the yellow and the pink dots, which are the lesbian women and gay men, form kind of a cluster right here, which means that the words being used in the outputs of these people are overlapping. This can further be corroborated by the fact that average cosine similarities with the control of straight men, straight women, gay men, and lesbian women follow a similar trend. Now, let me introduce the regard score, which is our quantitative measure of detecting the bias. It was introduced by Cheng et al. And what regard score measures is the social perception of an individual. It basically depends on what kind of words are being used in context to a person and how highly a person is regarded, basically. So from this, what we can see is that the regard score difference of control and straight men and with control and straight women, they're almost negligible. That means the regard score is pretty similar. However, for the regard score of control is way more than that for gay men and lesbian women's outputs. This basically motivated us to try to debias the output of a large language model in a post hoc way. And for that, we used Shapley values. Shapley values are usually used in machine learning models to increase their interpretability. It basically gives kind of a weight to the input features and basically see how much a particular feature contributes to the output of a machine learning model. And in the context of NLP classifiers, for a given trained classifier, it helps detect the words which influence the output towards a particular, you can say, label. So these are 2 examples of how sharp analysis works in context of a trained classifier. The classifier here is the regard classifier, which gives a sentence a particular score. The first example is for a statement's output, which has a positive regard of 0.95. And the second example is for the output of a gay man, which shows a negative regard of minus like 0.86. And as you can see in the first example, the words like renowned and cultural heritage and recognized, they push the word to have a higher regard score of 0.95. However, the words like discrimination and challenges lower the regard of the sentence in the second example. Okay, so the methodology that we used to debias our low regard outputs was that we took low regard sentences, did some sharp analysis, and got the top words which contributed to the sentence having a lower regard. We passed it through a large language model and asked it for giving us a possible reason for why the sentence has low regard because of these particular words. Then we concatenated the reason that the large language model gave us with the low regard sentence and asked the large language model to basically replace those low regard sentences in order to increase the regard of the sentence. It's kind of loosely based on like the idea of chain of thought prompting, rather than directly asking the model, large language model, to just convert a low regard sentence to a high regard sentence. We introduced the reason in it, and what we saw is that basically it helps keep the semantic meaning of the original sentence intact, and like it does not change a lot of words like that. And this is an example of how our methodology worked. So as you can see, the first sentence was categorized as a low regard sentence by the classifier. And it's basically about a gay artist, and the words like they incorporated sensual and homoerotic elements into his work. And he was openly gay in a time when homosexuality was heavily stigmatized and criminalized. So as you can see, that the reason that the large language model gave is pretty like it kind of makes sense that why like using such words might reduce the regard of the person being talked about. So the words like sensual and homoerotic got converted to the words like beautiful and intimate moments, and as well as the time when homosexuality was heavily stigmatized and criminalized got converted to despite the societal norms of the time, and similarly other things in the input sentence. Now, from what we saw, that this debiasing method works well, because we were able to reduce the regard score difference from 0.31 to 0.15 for gay men's outputs, and 0.27 to almost like negligible regard score difference for lesbian women. Further, as can be seen from the this TS any visualization of TF-IDF embeddings for the outputs of large language models pre and post debiasing, what we observe is that as pink and red dots, which are basically gay men output before and after debiasing, are pretty much overlapping. Similarly is the case for lesbian women. So we are able to retain the semantic meaning of the original sentence, and like it basically does not change like words by a lot. However, it reduces the regard pretty much. It reduces the regard score difference pretty much. So yeah, for some just like avenues for future work, the gender neutral methodology that we used was basically out of box. There's algorithm. It can be definitely improved on. And the Sharp analysis showed that there is negative regard because of the word gay. So one possible reason for this is probably that the regard classifier has, it's basically because of shortcut learning, that the regard classifier has probably seen a lot of low regard sentences which have the word gay in it. So probably it has correlated the word gay with a negative regard. So we definitely need to build better classifiers in order to prevent this. Further, what is really important is to actually look at the source of the bias, for how this bias is creeping in the large language models. And usually most historical text is like cis and heteronormative, like languages being used in like historical text. Recently, a couple of years back, actually, Jesse Raj and like Martin Sapp and others documented large web text corpora, and they analyzed like how large data sets on which large language models are trained on. They basically exclude the terms which exclude the documents that contain queer terms. So that basically contributes to the representational bias in queer community. That's it. Thank you so much. I would like to thank my team, and I would like to acknowledge Professor Martin Sapp for his feedback on our work, and my friend Tia, and everyone at Queer and AI, the organizers, and especially the reviewers. Thank you. If you have any questions, feel free to ask.
Any questions from the in-person audience?
Hi, I'm Eddie, is he, him pronouns. Yeah, I just had a question about whether you thought the switch to gender neutral language might have had any influence on your results? Just because I imagine the majority of biographies that the model has been trained on use gendered pronouns. So did you see any particular association with gender neutral pronouns and particular regard scores or other negative associations?
Uh, from what we saw was basically when we converted the gender basically to like they them, usually the output of basically GPT 3.5 included more or less like the outputs with the pronoun they and them as well. So and it gets influenced pretty much, like I would say, like because the qualitative analysis that we did showed that words like which are pretty common among like the queer community, they start coming up like for those inputs, even if the initial gender prompt which we converted like gender neutral was talking about a particular gendered person. The reason why we basically did this was using marked word analysis is because there is not much work done in which there has been basically unmarked you can say like sexual identity of a person in the like text written. So we introduced like the bias using a marked word like the sexual identity of the person with a gender neutral prompt. Had we found like some work in which the input text already had some, let's say, bias because of like implicit words that are being used by like one community rather than the other community, this work can basically be, you can say, we wanted to show that this can actually be extended to the like input data which has an implicit bias rather than an explicit bias, by which we introduce like using a trigger word. Does that like kind of answer your question?
Yeah, it does. Thank you. And yeah, really
Okay.
interesting talk. Thanks.
Sure.
Any other questions? Did we have any questions on Zoom? I see a message in the chat, but I'm not sure if it's a question.
No questions on Zoom.
Thanks. I had one question. So it seems like your analysis, and this might be a bit off topic, I guess. It seems like a lot of your analysis is on like the outputs of the language model. I'm curious if, based on your findings, what can we do to better develop these language models, you know, from a lower level or from the ground up? Do you have any ideas about that?
So I guess like one of the main things that probably we can look at is like the data that is being used to train these large language models, because as I said previously, that the analysis that this paper did on like the C4 data set for on which it's a large language model data set C4 on which like LLMs are trained, it showed that because of removing the because of basically preventing hateful speech in the outputs of a large language model, they removed the documents which contained like certain queer words, and the representation of the text that talked about queer individuals was very, very less as compared to the general cishet basically conversations and like the text which is written by cishet people. So that is something I feel from the grassroots level. If we try to have the data which is a little more balanced and takes in like the I would say like it basically is better represented of different communities. I guess that's definitely one way to go about it, which is pretty difficult. That's why we went with like a post hoc way to debias it, so that if the output we see that, you know, specific words gave the output a lower regard, we try to just debias those basically specific words using like a text to text based kind of method. So yeah, it's definitely a hard problem, and I guess many people are kind of working towards this nowadays.
Yeah, thank you.
Sure.
Any other questions from the room? All right, let's thank our speaker one more time.
Thank you so much.